Okay, so with equivalent rationals, the question I asked was, is 2x squared minus 6x over 4x cubed equivalent to x squared minus 3x over 4x squared? So equivalent means they're the same. So if I gave you a quarter of a pizza, and you had a quarter of the pizza, if you multiplied by 2 and say they cut the pizza into 8 pieces instead of 4, you would now get 2 out of 8 pieces, but you'd have the same amount of pizza, correct? This is equivalent to this. If I had 2/8 of a pizza and I divided it by 2, top and bottom, I'd get a quarter. So as long as you do the same to the top and the bottom, you're doing equivalent. Okay? Difference between equivalent and simplification. Equivalent, you can multiply. Simplification, you can't multiply because you're trying to make it more simple. If you multiply by something, are you making it more simple? No. You open the door for her. So, equivalent, we can multiply the top and the bottom by the same thing, or we can divide the top and the bottom by the same thing. So if you didn't remember that, you're going to write that. So that's the big difference between equivalent and simplification. Simplifying, you can make smaller and reduce by division only, but equivalent, you can multiply and divide. So I'm going to look at these two, and I'm going to say, what could I do to number 1 to get the first part to get to part 2, or what could I do from part 2 to get to part 1? Does it matter which way I go? No, it just matters that I show that they're the same. When I do stuff, that's the same. Okay? So in the first one, I could divide the top and the bottom by 2x. Or to the second one, what could I do? If I wanted to make them be the same. Well, it would be different because these are actually not equivalent, right? So if I look at this, I can say, I always look at the monomial. So in this case, I'm going to look at the denominators because they're easier to try and make be the same, right, than trying to make two terms be the same. So I'm going to look at this one and this one. So I like multiplying personally rather than dividing. It's just something I like doing. So I go to the smaller one and try and make it be the bigger one, but you could do either way. It doesn't matter. So this one's 4x squared, and I want it to be 4x cubed. What would I multiply by? X. And equivalent means what I do to the bottom, I have to do to the top. So if I multiply by x on the bottom, I have to multiply by x on the top. And I'm going to be left with x cubed minus 3x squared over 4x cubed. Is this this? No. So are they equivalent? Okay. Second question I asked you. The rational expression. Ax squared minus 3 over bx plus c is equivalent to two x squared minus 1 over 3x plus 1. Determine the value of a, b, and c. Now, on a diploma, this would be asked, this would be asked as either a numeric response, and they could say put A, B, and C in the first, second, and third column. Or they could say A, B, and C respectively. What the heck does that mean? No. Respectively means in that order. That's the way they say it. They don't say in this order, in the order A, B, C. They say A, B, C respectively. Keyword respectively, in that order. And I'm going to repeat it every day until the diploma. Respectively means in that order. Okay? No, it's the same word every single time. It's not like they switch it up. It's respectively, that one word. Okay. Now, they could say the sum of A, B, and C. What does that mean? What's sum? Addition, right? What if they said the product of A, B, and C? Multiplication. Quotient, they won't, but what does quotient mean? The answer to a division. And what's the answer to a subtraction? Difference. Okay? So this says equivalent. So the key word here I'm going to think of is equivalent. I'm going to go there, I'm going to highlight it on my diploma, or I'm going to underline it, because that is the key word here. I need to figure out what I can do to one of them to make it be the other one. Equivalent means the exact same. So I have to do the same to the top and the bottom, whether it's division or multiplication. What's the only thing that they share that we can actually see? The -3. And it corresponds with what on the other one? -1. So I'm going to move from this one to that one. I'm going to move from the second one to the first one. Why am I going to do that? The other one I had options. Why does this one not have options? Because I only know numbers on the second one, right? So I'm going to say, what did I do to the second one to get the first one? What did I do to the second one to get the first one? You multiplied by 3, which is true. Why did we not multiply by -3? Right, and it stayed negative. So, multiply by 3. Because it says equivalent, what does that mean? Do it to the bottom. So, I'm going to have 6x squared minus 3 over 9x plus 3. Now, there's people who give me signs. There's people who try and fill negatives into numeric response boxes still. You can't. There is no negative bubble. You can't fill a negative into numeric response. So either you're filling it in incorrectly and you got a wrong answer, or the question is bx minus c, let's say. Say it was bx minus c and this was 9x minus 3. What would c be then? Just 3, correct? If it was bx minus c and this was 9x minus 3, the minus signs would be shared and c would be what was beside the minus sign, right? Which would be 3. Okay? So you don't have to state negatives if it's in that case. So you always state what the value is beside what you're looking for. So we want to know what a is. Okay? So a lot of people try and simplify this after. Did it ask you to simplify it? No, don't go crazy. You're done. Just fill in the numbers. So what's beside x squared is a. So what's beside x squared is 6. So I know a equals 6. Do I care about this? No. We're happy. They match. Yay. Okay. What's beside x is b. So what's beside x is 9. So b equals 9. And what's beside the plus sign is c. So c is, okay? So not super difficult by any means. Remember, if you have not written the sinusoidal test, it has to be written by the end of this week. Okay, 3. 3, the question I asked you for 3 was, determine the NPVs. NPVs are only found in the denominator. Is that a true statement? NPVs are only found in the denominator. Is that a true statement? Technically, that is true. NPVs are only found in the denominator. Technically, that is true. We agree? Because division, you're like, except for division. No. Technically, NPVs are only found in the denominator. And why is that? Why are NPVs only found in the denominator? Because in division, you flip it. And then at the beginning, this denominator now becomes numerator. That's great, but it was in the denominator. And the numerator goes into the denominator, so it's still in the denominator. So we are technically only stating things that are in the denominator. Now, why do we have NPVs? You can't divide by 0. And we have what in the denominators now, as opposed to every other year before this? We have letters or variables in the denominator. If we only had numbers in the denominator, would we have to state NPVs? No, because those numbers would not be 0, and yay, we'd be done. Woohoo, no NPVs. The only reason why we have state NPVs is because, or non-permissible values, or they could be called restrictions, right? Restrictions on the variables, in other words. The only reason why we have to state non-permissible values is the denominator cannot equal 0. So we have to state what those variables can't be, because if they were that, the denominator would be 0, and we'd have problems. Okay, that's why we state NPVs. So true statement, NPVs are only in the denominator. Now, A. We have 12p squared minus 8p over 6p cubed minus 4p squared. Okay. Rules about any type of rational. It doesn't matter for simplifying or for multiplying or dividing. The very first step you have to do is always what? And it's not state NPVs. What's the very first step you always have to do in simplifying and multiplying, dividing? GCF or? Nope. GCF or difference of squares, right? We have to do GCF or difference of squares. So we're either going to do GCF or factor. We need to simplify them as much as possible because right now I can't state NPVs. If I went to go state NPVs, I'd say 6p cubed minus 4p squared can't equal 0 and then have to solve that. That's awful, first off, because you're going to have a p and a p on both sides. Too many p's. Okay? So what we have to do first is GCF or difference of squares. Do we have to do it to the numerator in this case? No, only because I'm asking for what? NPVs. If I asked you to simplify, would you have to touch the numerator? Yes. So we only care about the denominator because it says NPVs. And this isn't division. So we look at our denominator and we go to simplify it. What can that simplify? What can I take out of it? It's a GCF. A 2 and a p squared. What can I do with this 2 and p squared? I told you guys, it's every single time in rationals to do. Separate them. Put them in their own brackets. This 2 is in its own bracket. This p squared is in its own bracket. Why are they in their own brackets? Because they're not connected by a plus or minus sign. They're not a couple. They are separate entities because they are multiplied. Okay? They're separate. They're multiplied. So now what we have left over, 6p cubed divided by 2p squared is 3p. If you have a problem taking a GCF out once you've put these in separate brackets, then only put them in separate brackets after you've taken the GCF out. Some people look at this and like, oh crap, then they only take the p squared out or the 2 out, or they don't know what to do, and now they're super confused. So if that is you, which is going to be most of you, because that is just how it works, it probably would have been me in high school, leave it as 2p squared, take the GCF out first, then separate them. Okay? That's what I would recommend anyways. So 6p cubed take out of 2p squared is 3p, minus 4p squared divided by 2p squared is 2. So now I have all these things in their own brackets. Why is the 3p and the minus 2 not in their own separate brackets? Because they're together. Because they're attached by a negative sign, a subtraction sign. Okay, so I go to state NPVs. 2, can it ever be 0? No, it's 2. Okay, so this isn't going to get me an NPV. Nothing. I don't get anything from that. Don't really care. Okay, p squared, p cubed, p to the 5, p to the 7, p to the bajillion. What's my NPV for that always? 0. So p cannot equal 0. This does not mean x. This is not an NPV of x. I regret doing this now because someone's going to come back here and be like, oh, it's x and p can't equal 0. Why is she using x's? She's not. There's no NPVs here. No NPVs. I take away that x because that's going to cause issues. I can see it already. Okay. So we have p cannot equal 0. And then 3p minus 2. Please do it the long way. Don't go like 2/3 or 3/2 because half of you're going to get it wrong. So 3p minus 2 can't equal 0. 3p can't equal 2. Divide by 3. And p can't equal 2/3. So we have 0 and 2/3. And we're done. That's my answer. I don't have to simplify it because it doesn't say simplify. It just says determine NPVs. My b is 2y cubed minus 4y squared over 3y squared minus 9y divided by y squared minus 4 over y plus 2y minus 3. Now, we always state NPVs before we do what? We always state NPVs before we do what? Simplify. If you state NPVs after you simplify, will that answer be on your diploma? Absolutely. Because it's going to be your, no, it's because it's going to be your common error. If I'm writing a multiple choice question, I instantly put that one on because I know that more people are going to pick it, right? So you always have to state NPVs before you simplify. So what's the very first thing I have to do here before I can even state NPVs? Flip it or do what? You just need to simplify them, right? You don't even need to flip this. Do you have to flip it? No, we're only stating NPVs. Do I have to simplify the top left? No, I'm wasting my time because I'm only asking you for NPVs. If I asked you to simplify it, absolutely you'd have to do the top left, but why would you do that? Why would you do the top numerator on the left, right? Doesn't make sense. So I'm just going to leave that, and I'm going to simplify this. What can I take out of here? A 3 and a y, and I'm left with y minus 3. And then what would I do? Go back and do what? Put the 3 and the y in their own brackets, right? So people don't tell me y can't equal 3 or 4 or something crazy when they have the 3y beside each other. They do some crazy things. Don't do that. Okay. This one here, people forget about these. What is this? Difference of squares. Y plus 2, y minus 2. So many people remember it and then write y plus 4, y minus 4. If you FOIL that back, will that get you y squared minus 4? No. So you can always check your work. If you FOIL this back, y plus 2 and y minus 2, does that get you y minus 4? Yes. We're good. We did it right. Okay, and then this one's done for you. Yay. So we're going to go back and we're going to state NPVs of each. Does this one give me an NPV? No. It's not 0. We went over this exact same thing with my... It doesn't exist. There's nothing. Oh my gosh. Okay, and then this one is y can't equal 0. This one, y can't equal 3. This one, and done? No, it's division, so you have to do y can't equal negative 2, y can't equal 2. They're going to have an NPV for this answer, this question. I can instantly give you answers to multiplication, okay? They're going to give you just the denominator as one of the answers. Wrong. They're going to give you every single one of them, even the top left. Not correct. They're going to give you that, which is not correct. And then they're going to give you this flipped and just the denominators. That's the 4 answers right there. Done. This is a really easy question to write. Okay? So our NPVs are y can't equal 0, 3. Do I have to state 3 twice? No. Do I have to state negative 2 twice? No. And I'm going to go plus or minus 2. Okay? And the last one I have on the board right now is simplify. Simplify can be used for everything but solving. So I can just say simplify, and you would have to do multiplication, division, just plain old simplification, addition, subtraction. All of those, the key word I can ask you to do is simplify. How do you know what to do? By the operation that's between the rationals. Okay? But all of them have the same lead into it, simplify. The only one that doesn't is solve when there's an equal sign, because I'm asking you to solve. What does solve mean? Tell me what the variable equals, right? Whenever I say solve in math, no matter what unit I'm in, if I say solve, I'm asking you to tell me what that variable equals. So you'd have an answer like x equals 4 or something like that. Okay, so A, C minus 4, 4 minus C. I gave you this one because I wanted to see if you remember this, because they do this on the diplomas all the time, and I do it on unit tests all the time. I give you this as part of a multiplication or a division, not just nice and quick, just short like this, right? I put it as one of the questions into a multiplication or something like that, right? Make sure your phones are away. I'm not doing this for my benefit. All right. So what can I do to the top left, and what's the difference here between these two? They're flipped. They're the exact same letters and numbers, but wrong signs. And exact wrong signs. Like they're completely the opposite sign. So what can I take out? -1 every single time this happens, okay? So I'm going to take it out of the top because it's easier. You can take it out of the bottom. It doesn't matter. You're going to get the same answer. So I'm going to take a -1 out of the numerator, out of the top. And we're left with -c plus 4. And then on the bottom, I have 4 minus c. What about these two? They cancel. What do I have to do before I cancel? I slap my hand and I say state NPVs, okay? So before you go to cross off, slap your hand and be like, no. Have I stated NPVs? No, I have not. So I must state them. So I have form. Oh, I'm going to go off to the side. I'm going to solve this. 4 minus c cannot equal 0. Add the c over. 4 cannot equal c. If you can't spot that this has to be a 4, 4 minus 4 would be 0, okay? So we state our NPVs first. Then these two cancel, and my answer is -1, and then I state behind it c can't equal 4. I always give my answer, and I state my non-permissible value behind it. That is the correct way to go about this, because -1 is not the answer. -1 and -c plus 4 cannot equal is the right answer. Okay. B. B is 3x squared plus 15x over 6x squared minus 3x. So it's just a basic simplification again, but more work, right? What do I have to do here? Yes. Take out a GCF on the top in the numerator and the bottom in the denominator. So in the numerator, I have to take out a 3x, and I'm left with 5. And then what do I do with that 3 and that x? Because they are not together because they're multiplied. What can I take out of the bottom? Okay, 6x squared divided by 3x is 2x. What is 3x divided by 3x? 1. Now, most people will catch this because it's a -1. But if it's a +1, people are like, it's just gone. No, it's not. Okay? Make sure you have a 1. So it's 2x minus 1. Now, what can I do before I cancel? What do I have to do? And I know this is exciting because you're like, 3x and the x go away. Yay. And you get excited and you're like, I did something right because something will cancel. This is awesome. And I know you get excited and you want to cancel them. But you have to state NPVs first. So 3, is it an NPV? No. X, what do I get? And then what about 2x minus 1? I say 2x minus 1 cannot equal 0. Add the 1 over. 2x cannot equal 1. And x cannot equal half. Seriously? X cannot equal 0 or a half. Now I have my NPVs stated. I can cross off the x, I can cross off the 3, and I can cross off the x and the x here. No. Because that's what you would have done at the beginning of the year. So, don't do that. This is x plus 5. The only way it's going away is if there is a x plus 5 in the denominator. Is there? No. 2x minus 1 is only going away if there is a, and there is not. It's not going to be prettier than this. It doesn't have to be an answer of like 5. Okay? Don't make it be like that. But always check and make sure that you actually did a difference of squares, because I find that's the only place where people mess up, is they forget to do the difference of squares. So I often will have an extra factor in here as x squared minus 4. Okay. I'm saving you. Just be quiet. Okay. Yeah, you don't even know. All right. Okay. So then C is y squared plus 4y over y squared minus 16. Shh. The top, you can take a y out and you're left with y plus 4. The bottom is a difference of squares, y plus 4, y minus 4. And you have to stop yourself because you're going to try and cross these off right away because you see that they work out and you're happy. NPVs. So we have y can't equal plus or minus 4. Then these can cancel, and you're left with y over y minus 4. What do you have to stop yourself from doing? Crossing these y's off. Now, what happens if I had this? Because some people do have this, and then you get it wrong. So say I had x plus 3 over x plus 3x minus 3. What would happen? These would cancel. And what do people tell me the answer is? It's 1 over x minus 3. And a whole bunch of people will tell me it's x minus 3. Is it just x minus 3? No. If this cancels, you have a 1 on top. This would actually be equal to 1 over x minus 3. If you're someone who would not have done that immediately, write this down as a little reminder to yourself, because you will do that and you will get it wrong on the diploma, because those are what they do. Okay? So you have this, and you have y can't equal plus or minus 4. Okay, D, I'll do here, 2b squared minus 18b. Why would I pick this one? I picked this one specifically because a whole bunch of people don't know what b minus 9 squared is. What I tell you whenever you get a b minus 9 squared, what should you instantly do? Cross out that squared and do what? Write it.
Plus 9 beside it.
No, it's not a plus. It means you have 2 of them. Yes. So when you cross this off, you have a b minus 9 and a b minus 9, not a b plus 9, which is what people always tell me. Okay? Now the top I can take out a 2 and a b, and I'm left with b minus 9. Put brackets around the 2 and the b separately. On the bottom, I have b minus 9, b minus 9. Quiet, please. B cannot equal 0 and 9. B's cancel, the b's cancel. And I'm left with 2 over b minus 9. B cannot equal 0 or 9. Number 5. So you have 6y minus 30 over y minus 1 times 5y minus 5 over 3y squared minus 15y. Now when I see this, I think every single one of you should be able to get this correct. It's not ridiculously hard. There's nothing weird about it. You literally just go to each one, and there's not even a difference of squares. They're all GCFs. And the bottom left, there's nothing to do to it. So there's no flipping, there's no nothing. So on the top, you can take out a 6, and you're left with y minus 5. 6 in its own brackets. On the bottom, you have y minus 1 in its own brackets. Nothing you can do to it. In the top, you can take out a 5 in the top numerator on the right. And you're left with y minus 1. Now, if that's 5y plus 5, it scares me. Why does 5y plus 5, if I see that on the diploma, scare me? Because people will take out a 5, and they'll tell me it's 5y. If you distribute that back, do you get 5y plus 5? No, then you're wrong, okay? So if you have 5y plus 5, and you take a 5 out, you're left with y plus 1. A whole bunch of people say 5y, okay, y. 5 plus 5, 0, it's gone. But if you wrote the answer as 5y, if I distribute that back, do I get this? No, catch your mistake. Think, if I distribute it back, do I get that? If I do, if I don't, I'm wrong, okay? Think backwards. If I move back, do I get back what I have? The bottom, I take out a 3y, and I'm left with y minus 5. The 3 and the y are in their own brackets. Okay, so I state my MPVs. Y can't equal 1. The 3 doesn't get me 1. 0 and 5. Do I care about the top? No, because this is multiplication. Now once I stated MPVs, I can cancel. So anything on the top and the bottom on either side can cancel, right? Numerators and denominators. Now, if there was a y minus 1 here and a y minus 1 here and only one y minus 1 on the bottom, could I cross them all off? No, it's 1 for 1. Okay? 1 in the numerator crosses off 1 in the denominator. It's not a 2 for 1 deal. There's no buy one, get one free. Y minus 5, y minus 5. And then say you don't catch that you can take the 3 out. Say you don't catch you can take 3 out. That's fine. Go move on. 6 times 5 is 30 over 3 times y, which is 3y. And now you catch that you can take it out. Doesn't matter if it takes you an extra step. Absolutely not. No big deal. No one hurt. Okay? 10 over y. Y cannot equal 1, 0, and 5. And what did I ask you to do here? I would have said simplify, right? Okay, and then b, 4a squared minus 1. This one is complicated. I picked this one for the very reason that it is a little harder than the other ones, because there's a few different steps. Yes? Why would that change? Okay, so the top left,
I'm just getting physical in my bag. What?
so this is a difference of squares. I'm going to get 2a minus 1, 2a plus 1. What's the catch with the bottom? People will say it's a difference of squares, but what should you have done first? Take a 4 out. Then you're going to actually notice the GCFs of 4, and then this is the difference of squares. A plus 2, a minus 2. You can flip it. You have 2 minus a. I'm going to take a negative 1 out, and I'm going to be left with negative 2 plus a. And then on the bottom, I have 2a minus 1. I have to say NPVs for everything but the top left, the numerator on the left. And I have to have equal signs as I go along because this is equal to this is equal to this. They're simplified, right? They're all equal to each other. So a can't equal plus or minus 2 or a half. Now, 2a minus 1 and 2a minus 1 cancel. A minus 2 and negative 2 plus a are the same. They cancel. And on the top, I'm left with negative 1, 2a plus 1 over 4a plus 2. Now, what if they asked for the solution like this? So please pay attention. What if they asked for the solution like this? Ma plus b over 4a plus 8. What's m and b? What are they expecting you to do? This is a good answer, and it's simplified, but what are they expecting you to do? Distribute this back in. This is brackets. Does this have brackets? No. So you'd have to distribute this in and then give me the answers. Okay? So if this solution down here doesn't have brackets and this does, you have to distribute it back in. Do they usually ask that? No, but they could. Just a note to self. Okay. So then we have a can't equal plus or minus 2.5. And then the last one we're going to do today is the area question. So I asked you for the area of that rectangle. Area means length times width. So what am I just asking you to do? Multiply. So you're going to get 2x cubed plus 4x squared over 5x times 20x over x plus 2 squared. And what do I do instantly when I have an x plus 2 squared? Write x plus 2 out twice. The top I can take out a 2x, and I'm left with 2x squared, sorry. And I'm left with x plus 2. Just wait. You can all wait. Over 5x. Put these in separate brackets. Times 20. Ooh, don't know where I was going with that. 20 times x. When you're talking when I'm teaching, it's rude, just in case you haven't caught on to that. You state your MPVs. X can't equal 0 or negative 2. 1 for 1. You can't take 2. An x for an x. Could I have taken an x off the x squared? Yes, but only one of the x's. Because x squared means x times x, just like x plus 2 squared means x plus 2 times x plus 2. The 20 and the 5, I can take a 5 out. 5 divided by 5 is 1. 20 divided by 5 is 4. And I'm left with 8x squared on the top. And on the bottom, I'm left with x plus 2. And x can't equal 0 or negative 2. Now, my thing for you is these need to be completed. I will be checking these on Wednesday. If you don't have them done, you can stay in at lunch with me because I'm not doing all of this for myself. Okay? 7 and 8, you need to do them. No, you'll stay in for lunch, or you can do 4 questions that I asked you to do.